Welcome to another video tutorial for Learning Music Theory with Logic, Max, and Finale, published by Routledge and written by Jeffrey Kidda. In this tutorial, we'll discuss chromatic music. We'll discuss atonal music versus chromatic music, which is still tonal. We'll discuss how you can group notes together in atonal music into trichords, tetrachords, or hexachords, which are 3-note groups, 4-note groups, or 6-note groups. We'll talk about a development in atonal music called 12-tone music. We'll see how one of the tools that composers use in creating 12-tone music is the 12-tone matrix. We'll see how we can name the pitch sets, which we can use in atonal music, other than the trichords, tetrachords, and hexachords. And then finally, we'll take a look at the chromatic melody generator, which allows us to create chromatic melodies. We should start by remembering that in tonal music, we build our chords with thirds. And when you build chords with thirds, you're creating tertian harmony. It's the basis for tonal music. Harmony, in the form of triads, seventh chords, or extended chords, is always built using thirds and is thus named tertian. Tertian harmony is at the core of tonal music, both diatonic and chromatic forms, and it's arguably the harmonic basis for the vast majority of musical creation in the Western tradition. Atonal music has no key or tonal center and is not necessarily based on tertian harmony. Composers started writing atonal music in the early 20th century, when tonal music was increasingly using chromatic elements. As an example, we could listen to the composer Max Reger, who pushed the limits of tonality by frequent modulations and far-ranging chromatic harmony. Reger, however, always indicates a key, and the musical structures are tertian. As an example, we have an excerpt from Max Reger's monologue for organ, the first movement of this set, which is called the Prelude. This is still tonal, but is very chromatic. Reger indicates that we are in C minor in the score, and he has a key signature of 3 flats. The first phrase, which we will have a version of here, ends with an A major triad, and there are no discernible cadences in C. Composers Arnold Schoenberg, Edgar Varèse, and many later composers went further than Reger, writing music that wasn't in a key and didn't rely on key centers or tertian harmony. In place of tertian harmony, these composers relied on musical structures consisting of a certain number of pitches. 3 pitch groups or sets are termed trichords, 4 pitch sets are called tetrachords, 6 pitch sets are called hexachords. We can say that triads are a subset of trichords because we can also say that triads are trichords built with thirds. Seventh chords are a subset of tetrachords, as seventh chords are tetrachords built with thirds. Even if the triads or the seventh chords are inverted, we can still figure out that in their basic form, they are built in thirds. To begin thinking about atonal music, we could randomly generate trichords with logic. And if we want to make sure that the trichords we're using are not heard as tonal, we can exclude the triads and those with repeated notes created in the random process. First, we'll set the time signature to 3/4 and create a 1-measure region. We'll add 3 notes to the region on middle C. We'll create multiple copies of the region, and then using MIDI transforms random pitch, and making sure to keep the pitches within 1 octave, will create many trichords with random pitches. As we listen to the trichords, we'll make sure to exclude those where triads were formed or repeated notes are heard. We've selected a trichord to work with, and we can use MIDI transforms transpose transposition function to transpose it. We can also use the edit menus transpose functions as well. First, we'll hear the transposition by one semitone ascending. Next, we'll hear the transposition by three semitones ascending. Next, we'll hear the trichord transposed by four semitones ascending. And finally, we'll hear the trichord transposed by five semitones ascending, and notice how this sounds a little bit like the circle of fifths. We could take a trichord and apply pitch operations to the trichord in much the same way as we took a diatonic motive and used operations to create a larger melody. We can transpose the trichord by different amounts. We can play the trichord backwards or retrograde it. We can have the mirror image of the trichord, which is the inversion, and then we can combine the retrograde and the inversion to create a retrograde inversion form. First, we select a trichord, then we option drag it forward to make additional copies. We use MIDI Transform's reverse position to create a retrograde form, setting the position by measure numbers and beats. We use MIDI Transform's reverse pitch to create the inversion, setting the flip to the first note of the motive. We combine reverse position and reverse pitch to create the retrograde inversion of the motive. We'll hear a musical phrase built using just one trichord, heard melodically and harmonically in various forms. After Schoenberg was writing atonal music, he developed another system which he termed the 12-tone technique. The basis for 12-tone music is to construct a row or series using all 12 pitches of the chromatic scale. The row can be used melodically or harmonically, and it becomes the generative source for the music, much as one might say the major or minor scale is the generative source of tonal music. It's important to remember that how the rows are used differs by composers and by compositions. Arnold Schoenberg's most well-known students were Alban Berg and Anton Webern. With Berg and Webern, we can actually see two quite different ways of creating 12-tone music. Alban Berg's violin concerto is remarkable among 12-tone compositions in that the row itself contains a number of triads. Just as with other musical lines, the row can be transposed, retrograded, inverted, and these operations can be combined in different forms. We can use Finale's transposition and canonic utilities to create these forms. When you think about transposing the rows, you realize that you have 12 different possible rows, but you can also retrograde each of these, so then you have another 12 possible row forms. You can invert the row on any pitch, and you can play the inversions backwards or in retrograde form. So all told, you have 48 different possible row forms. Composers sometimes would create what's known as a 12 by 12 matrix, which gives you all of the row forms, the prime and transpositions, the retrograde and transpositions, the inversions and transpositions, and the retrograde inversions and transpositions. Here's a short excerpt from the Berg Violin Concerto, where we hear the row in the violin. As we mentioned earlier, atonal composers sometimes thought about sets of pitches or groups of pitches. In addition to the 3, 4, and 6 note groups, which we mentioned already, the trichords, tetrachords, and hexachords, you can also group pitches in 2, which is the dyad, or in 5, which is the pentachord, and larger than the hexachord, you have the septachord, octachord, nonochord, and decachord, which have 7, 8, 9, and 10 pitches. We can use the transposition tool in Finale to transpose a tetrachord up by major seconds. And notice when we have transposed this particular tetrachord up 3 times, we get the same pitches as we started out with. Just as we were able to invert triads and 7th chords with the canonic utilities, we can invert a tetrachord with the canonic utilities. In this case, since the tetrachord has 4 pitches, we will have the original and 3 inversions. We can use the canonic utilities chromatic mirror inversion to invert the tetrachord. We will make sure that the pivot note is set to the lowest pitch of the tetrachord, and then we'll see a mirror inversion of the chord. Atonal music theory incorporates the idea of pitch sets, and in fact focuses on the idea of pitch sets quite a lot. One of the tetrachords that has garnered interest among atonal music theorists is the so-called all-interval tetrachord, which has all of the intervals or their inversions represented. As an example of an all-interval tetrachord, we have the music here of C, C sharp, E, and F sharp. All of the 4 pitches can be combined in different ways to create all of the intervals up to an octave. Not all tetrachords have this particular property, and much of atonal music theory is focused on the properties of pitch sets and how they sound. We'll have an example, a short example of an all-interval tetrachord used in various forms. Finally, to investigate chromatic music, we can use the Chromatic Melody Generator, an app created in Max. And like the diatonic melody generator, we have the ability to create motives of different lengths, in this case 3, 4, 5, or 6 notes, and we'll combine those motives to create a melody of up to 40 notes. We can combine different rhythms to create a rhythmic motive from a 16th note to a whole note. And once we have our pitch motive and our rhythm motive, we can create various melodies by combining the motives with different operations, such as prime, retrograde, inversion, or retrograde inversion, and the transposition of all of these pitch motives. We can also combine the rhythmic motives either in the prime or retrograde form. We have then the pitch melody and the rhythm melody, which we join together to create the melody itself. In the next example, we're going to create a chromatic melody with a chromatic melody generator using 6 instances of a 6-note motive to create a 36-note melody. First, we'll set the motive length to 6, and then we'll set the melody length to 36. Then we'll input our pitch motive as C, C sharp, F, E, G sharp, A, and we'll input our rhythm motive as 4/8 notes and 2 quarter notes. Then we'll make our pitch melody out of the following forms: the prime form at 0, the prime form transposed up 2 semitones, the retrograde form transposed up 6 semitones, the retrograde form transposed up 5 semitones, the prime form transposed up 7 semitones, and then the retrograde at pitch 0. We'll make the rhythm melody as prime, prime, retrograde, retrograde, prime, retrograde. We'll then join our rhythms and our melodies together into the melody, and we'll be able to listen to it. First, we'll change the melody length to 18 notes. So we'll cut it in half, but we will make the rhythmic durations twice as long. So as opposed to eighth, quarter, we'll make them quarter, 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 half, half. Then for the melody, the pitch melody, we'll use inversion at 0, inversion at -2, and then prime at -12. And for the pitch melody, we'll use 3 forms of the prime. We recorded both the melody and the bass line in Logic, but we didn't synchronize them, and so now we can do a quick adjustment and put them together without necessarily worrying about if they're exactly synchronized. If you are familiar with working with MIDI and DAWs, you know that you can do lots of things to make MIDI tracks synchronize. We'll also pan them left and right, and the result is here. Thanks for watching.